Okay, question 2. We have 3 sub-questions. All of these we need to answer whether it can be autocorrelation function or it can be spectrum density functions. So to answer these questions, we need to know some basic rules. The first one, we need to know if xt is real and while in stationary process. And we have some for r tau, we have to achieve 3 conditions. The first one, r tau is always small or equal to r0. And the second one, r tau is even. And the second one, the Fourier transform. Let me see the Fourier transform. Fourier transform form of r tau is non-negative, which means it's bigger or equal to 0. And for the density function, is omega, we need to achieve the only condition is S omega should be non-negative, which means it was bigger or equal to 0. So it may be the density spectrum, power spectrum of a while in stationary process xt. So use these 4 conditions. We should, the first one, Fv equals to E minus V. So for r tau, first, even, because E minus V equals E minus V. So it achieved the second one, E minus tau, or E minus 0. This one, because it was minus, so it always achieve that the tau, E tau, is smaller than 0. The third one, the Fourier transform of f tau, the Fourier transform will be 2 alpha over alpha square plus omega square. And this one is always bigger or equals to 0. And so 3 is matches, so it may represent. And for power spectrum, because E minus V always bigger or equal to 0, so it may be power spectrum. So the two answer is all maybe. For question B, Fv equals to V square sine square V. This one, first, to F0 is, we can just do the limitation that tau equals to 0, sine square tau and tau square, which means it was 1, and it was bigger or equal to sine square tau of tau square. And for the second one, sine square tau over tau square, we can find it was even. And third, for Fourier transform, sine square tau of tau square, the Fourier transform looks like a triangle. 2 minus 2, 1 omega. This is non-negative. So we can know that it may be autocorrelation. And for f omega, because sine square v omega and omega square, the above part is bigger or equal to 0, bigger or equal to 0, so it was bigger or equal to 0. So it may be power spectrum. And come to the third one about f v equals to 1 or 0. V is small or equals to alpha. V is bigger than alpha. And so the first one, f0, 1 bigger or equal to f tau, 2 fv even. But the third one, the Fourier transform of f tau is non-negative. So the third one didn't match, so we can say it's not. And for f omega, we can easily see it was bigger or equal to 0. So we can see that it may be power spectrum. So this is the whole answer. The key point to know is to know how it can be autocorrelation and what's the condition it may be a power density function.